Meta just ruined Google with their new AI. Are we witnessing the end of search engines? But what does this mean for you? Will it revolutionize the way you browse the internet? Comment below. Are you ready to embrace the future or terrified of the consequences? Simple and controllable music generation. Meta, the renowned technology company, continues to make groundbreaking advancements in artificial intelligence. Today, they unveiled their latest innovation and exceptional achievement in music generation. In their newly published paper, Simple and Controllable Music Generation, Meta's AI division introduced MusicGen, a remarkable language model, LM, specifically designed for conditional music generation. Unlike previous approaches, MusicGen stands out due to its singular composition as a single-stage transformer LM. This innovative design allows it to seamlessly operate across multiple streams of compressed discrete music representation, employing tokens as its foundation. Notably, integrating efficient token interleaving patterns sets MusicGen apart, eliminating the necessity for cascading multiple models, a characteristic absent in earlier endeavors. MusicGen's ability to generate music across diverse genres, styles, and moods distinguishes it as a versatile and comprehensive tool. With Meta's continuous dedication to innovation, the MusicBot demonstrates the company's commitment to pushing AI's boundaries and transforming how we interact with and create music. The release of this paper marks a significant milestone in the AI community and augments Meta's ever-expanding repertoire of cutting-edge technologies. As the world eagerly embraces Meta's MusicBot and its potential applications, the future of music generation is poised to be revolutionized, fostering a new era of artistic expression and sonic exploration. One noteworthy aspect of the evaluation is the comparison between MusicGen and another model called MusicLM, specifically in generated competitive bass lines. However, it should be noted that the authors employed a public API for human studies to evaluate MusicLM, while they retrained the MusicGen model on the same dataset. This discrepancy in evaluation conditions raises concerns about the fairness of the comparison. Despite this limitation, the results indicate that MusicGen holds promise as a competitive approach for text-to-music generation, potentially surpassing the performance of MusicLM. The promise of MusicGen and its impact on the music generation landscape. The introduction of MusicGen marks a significant step forward in the field of music generation. Its simplicity and efficiency in generating high-quality music at a sampling rate of 32 kHz make it an appealing choice for composers, artists, and enthusiasts alike. The ability of MusicGen to perform both text and melody condition generation offers unprecedented controllability, enabling users to shape the musical output according to their creative vision. Moreover, the extensive evaluation and human studies conducted on MusicGen emphasize its superiority over existing basslines objectively and subjectively. The model's exceptional performance, as demonstrated by the high subjective rating, signifies its potential to create music that resonates with human listeners. The implications of this technological breakthrough extend beyond mere background music. While the new Meta AI MusicBot undoubtedly finds applications in settings such as hotel lobbies, video game soundtracks, or small-scale projects, its potential for creating entire music tracks serving as main themes is where it truly shines. The new Meta AI MusicBot draws its musical expertise from an extensive training dataset of over 20,000 hours of music. This dataset comprises a diverse range of music, including approximately 10,000 high-quality tracks from an internal collection and data from Shutterstock and 0.5 Music. However, despite the large volume of training data, some tracks were incorrectly categorized or inadequately sampled, leading to inconsistencies in performing across different genres. Nevertheless, the emergence of the new Meta AI MusicBot marks a significant milestone in AI-assisted music generation. As the technology progresses and incorporates user feedback, subsequent iterations are anticipated to yield even better results. The potential for the bot to become an indispensable tool for musicians, composers, and producers is immense. Its ability to effortlessly generate high-quality music tracks and its future potential for collaboration and customization holds great promise for the music industry. We employ objective and subjective evaluation metrics to evaluate the performance of MusicGen and the basslines. The objective evaluation encompasses three metrics: the Fréchet audio distance, FAD, the Kolbeck-Leibler divergence, KL, and the clap score, CLAP. FAD, computed using the official implementation in TensorFlow with the VGG-ish model, measures the plausibility of the generated audio. A low FAD score indicates that the generated audio is perceptually realistic. KL divergence, following the approach of Kriuk et al. 2022, is calculated using a state-of-the-art audio classifier trained on AudioSet. It quantifies the similarity in concept between the generated and reference music with a low KL indicating shared concepts. Lastly, employing the official pre-trained clap model, the clap score measures the alignment between the track description and the generated audio, providing insight into audio-text coherence. In addition to the objective evaluation, human studies are conducted to assess the quality of the generated music. Following the methodology of Kriak et al. 2022, human raters are engaged to evaluate two aspects of the audio samples: overall quality, OVL, and relevance to the text input, REL. Raters assigned perceptual quality ratings on a scale of 1 to 100 for the overall quality test. For the text relevance test, raters rate how much the audio aligns with a given text input on the same scale. Raters are recruited through the Amazon Mechanical Turk platform, and at least 5 raters evaluate each sample. Random samplings are performed to ensure an unbiased evaluation of this music AI. In our comparison, we assess Music Gen against existing models such as Mouse AI, Riff-Fusion, Music LM, and Noise to Music. Although Noise to Music has no official implementation or pre-trained model, we report the FAD, Future Affinity Distance, metric on music caps as mentioned in the Noise to Music manuscript. As for Music LM, we use the publicly available demo for subjective test and report the FAD as reported by the authors. While the original Music LM model is trained on vocal data, the API model used in our study is instrument only. Our human study focuses on 40 instrument-only samples from music caps to avoid potential data leakage. According to human listeners' evaluations, the results indicate that Music Gen outperforms the evaluated baselines regarding audio quality and adherence to the provided text description. Regarding objective metrics, Noise to Music achieves the best FAD on music caps, followed by Music Gen, trained with text conditioning. Interestingly, adding melody conditioning to Music Gen leads to slightly degrading objective metrics, but does not significantly affect human ratings. Nevertheless, the combined textual and melodic conditioning still outperforms the evaluated baselines. To evaluate the performance of Music Gen conditioned on both textual and melodic representations, we introduce a new objective metric called chroma cosine similarity. This metric measures the average cosine similarity between frames of quantized chroma from the reference and generated samples. We evaluate the model using 1,000 randomly sampled files from a held-out set. Additionally, we conduct a human study where raters listen to a reference musical piece followed by a set of generated pieces. Raters are asked to rate how well the melody of each generated piece matches the reference on a scale of 1 to 100. The results demonstrate that Music Gen, trained with chromatogram conditioning, successfully generates music following a given melody, enabling better control over the output. Interestingly, Music Gen remains robust even when the chroma information is dropped at inference time, with both OVL, overlap, and REL, relevance, scores remaining relatively consistent. As the video ends, we've witnessed how Meta has potentially disrupted Google with their groundbreaking invention. But what does this mean for the future of search and information access? Will Google be able to keep up, or will Meta dominate the digital landscape? Please share your thoughts, hit that like button, subscribe to our channel for more tech updates, and don't forget to comment below with your predictions and opinions.